Welcome students. In this video, we will discuss the question of AP Calculus BC 2022 free response questions, right? And the question number is 5. Previous questions are discussed in other videos, which you can watch in the playlist, right? So let us see the question. The question is figure 1 and 2. This is figure 1, this is figure 2. Illustrate the regions in the first quadrant. So this is the first quadrant associated with the graph y is equal to 1 upon x. So this is the graph of y is equal to 1 upon x and y is equal to 1 upon x square. So this is the graph of y is equal to 1 upon x square respectively. In figure 1, let R be the region bounded by the graph y is equal to 1 by x. As you can see in the graph, this is the region R and this is bounded by this graph y is equal to 1 by x and x is equal to 1. This line, let us this green line, this is x is equal to 1 and x is equal to 5 and this x-axis. So this is the region R bounded by the following curves, right? And in figure 2, the region W be the unbounded region. This is an unbounded region and between y is equal to 1 upon x square and the x-axis. So this is the unbounded region, right? That lies to the right of the vertical line x is equal to 3. So the question is clear. This is the graph of y is equal to 1 upon x. This is the graph of y is equal to 1 upon x square. There is a bounded region R shown in the diagram. There is an unbounded region W shown in the figure. Okay. So the first question is find the area of region R. So as we know how we can find the area. Area is, we can find area with the help of integration, right? We have to find area of this region R. This is bounded between x is equal to 1 to x is equal to 5. We can take x is equal to 1 to x is equal to 5 and we have to integrate it. So this is y dx. We have to substitute this y in terms of x. So this will be 1 to 5 and y is equal to 1 by x as it is given in the question. So this will be area. So integration of 1 by x is basically ln x with the limit 1 and 5. So we can find it ln 5 minus ln 1 and we know ln 1 is basically 0. So its answer will be ln 5 minus 0, that is the ln 5. So this is the answer of the first part, that is the area of the region R. Let us see the part B. The region R is the base of the solid. Let us visualize this. Let's clear this graph first. The question is saying this region R is the base of a solid. For the solid at each x, right, there are so many value of x. At each x, cross section perpendicular to the x-axis is a rectangle with area given by. So there is a rectangle on this base. You can visualize like this, perpendicular to this at every x. And its area is given by the area of this rectangle. These rectangles are basically area is equal to x multiplied by e raised to power x by 5. This is the area of these rectangles which are perpendicular to this base region R. And we have to find the volume of the solid. So how we can find this volume? Let us see. We can find volume. Volume can be written as area multiplied by thickness, right? So we can find it. Since area is variable, right? Dx thickness is variable, so we have to find first small volume. So small volume will be a of x, since area is variable, into thickness dx, right? So we have to integrate it both side with the limit. We have to put the limit. The base region is x is equal to 1 to x is equal to 5. V is equal to 0 to v is equal to v. Let us suppose initially volume was 0, full volume was v. So this is v with the limit 0 to v minus, equal to limit x is equal to 1 to x is equal to 5. And what is the ax? Ax is x multiplied by e raised to power, as you can say here, x by 5 into dx. Simply this will be v and we have to integrate this now. How we can integrate this, right? So there is a trick. As you know, when we have an exponential function and an algebraic function, first we have to integrate exponential function. The trick is, so integrate that function first, right? Or you can say leave that function which can reduce it to 0 after differentiating it, right? So algebraic function x, it can reduce itself after differentiation. So we can apply the Eilert rule. So Let us do its integration. Its integration will be v is equal to, we can left x and integration of this e raised to power x by 5 divided by 1 by 5 with the limit 1 to 5 minus integration of 1 into e raised to power x by 5 divided by 1 by 5 with the limit 1 to 5, and this is the dx. So v is equal to 5x e raised to power x by 5 with the limit 1 to 5 minus integration 1 to 5 into e raised to power x by 5 dx. So this will be v is equal to 5x e raised to power x by 5 1 to 5 minus, when we will integrate it again, this will be 25 e raised to power x by 5 with the limit 1 to 5. Let us substitute the limit. So we will get v is equal to 25 e raised to power 1 minus 5 e raised to power 1 by 5. This minus, this will be 25 e raised to power 1 minus 25 e raised to power 1 by 5. So when we collect this 25 e raised to power 1 minus 25 e raised to power 1 minus 5 e raised to power 1 by 5, and this will be plus 25 e raised to power 1 by 5. No, sorry. When we will take minus common, so this will be again a minus because there is a minus here. So this will be cancelled out, this will be 0, and we will get 5 minus 25 is a minus 20, and it's again minus, so that's the plus 20 e raised to power 1 by 5. This is the answer of second part. Let us see its third part, that is the part C. The part C is saying, find the volume of the solid generated when the unbounded region W is revolved about the x-axis. When this unbounded region W is revolved around the x-axis. Let us clear this diagram. So when we will revolve around the x-axis, the solid will be kind of this, and the cross section will be like this. So we have to find its volume. How we can find volume? Again, volume will be area multiplied by thickness, or you can say there will kind of disk, its area will be pi r square. What will be the r? Its r will be variable, here it is different, and so on. So basically r is different, and we can take r as the this function because its y value is giving us r. At every x there, the value of y will give us the value of r. So r is equal to 1 upon x square. It's the function. So we can find its volume, part C. So its volume will be equal to integration pi r square. We can take the value of r as 1 upon x square whole square, and thickness is dx. From where to where we have to integrate? X is equal to 3 to x is equal to infinity. As you can see in the diagram, we have to integrate from 3 to infinity because this is an unbounded region. So we have to evaluate this. V is equal to, again I'm writing 3 to infinity pi 1 upon x square whole square dx. Let us solve this. So this will be v is equal to 3 to infinity, this will be pi 1 upon x raised to power 4 dx. We can calculate this, no problem. So pi will be outside, and this will be integration 3 to infinity x raised to power minus 4 dx. We can apply the basic formula of integration, and we can write it pi, the integration will be integration of x raised to power n is equal to x raised to power n plus 1 divided by n plus 1. So this will be minus 4 plus 1 divided by minus 3 with the limit 3 to infinity. So this will be minus pi by 3 will be taken outside, and this will be x raised to power minus 3 with the limit 3 to infinity. So how we can find this? So we can evaluate this minus pi by 3. This will be infinity raised to power minus 3 minus 3 raised to power minus 3. So what is the infinity raised to power minus 3? We can think minus pi by 3. This is 1 upon infinity cube minus 1 upon 3 cube, or you can write directly 27. So 1 upon infinity, that is the 0. We can approximate it. Minus pi by 3 0 minus 1 by 27. So after multiplying this, we will get pi by 3 into 1 by 27, and we will get pi upon 21, right? So this will be the volume of this unbounded region W revolved about x-axis. Okay, students. So I hope you have understood this question very well. Thanks for watching.